Yesterday, on Earth Day, we hosted an event, Smarter Students for a Smarter Planet. The focus was on combining IBM's technology resources and Columbia academic programs, specifically engineering, alongside science, business, and law, to prepare students to enter a job market that is looking for engineers and applied scientists to create more sustainable buildings, electric grids, and transportation. Today, this panel will be specifically addressing the issue of the smart grid and the electric car. I want to thank each of the panelists for participating in this important discussion on the future of private transportation in New York and all other major metropolitan areas in this country. At this time, I would like to introduce the host of today's event, David Waltz, who will introduce each one of the keynote speakers and panelists. David is director of the Center for Computational Learning System. The center is a world leader in machine learning and data mining research, with a focus on the application of this research to specific real-world challenges, among them the electric power grid. Dave leads a group of researchers in smart grid technology who are working closely with both ConEdison and the US Department of Energy. Dave has served as president of the American Association for Artificial Intelligence and is a fellow of the Association for Computing Machinery. He's a member of several governmental and academic advisory boards, as well as the NSF Computer Science Advisory Board. Please welcome David Waltz.
Thanks, Fanny, and good morning, everybody. I'm very pleased to be part of this exciting event, and I think historic event. I've been a car lover as long as I can remember. When I was 11, my grandfather taught me to drive his 1931 Ford Model A truck, which had been shortened to serve as a tractor in his farm in Maine. And throughout the 50s, my friends and I eagerly anticipated every new, radically different car model and looked for them on the road as they arrived. We drew and shared pictures of our fantasy vehicles, and I lobbied my parents to get the flashiest and most powerful models I could do, without huge success, but better than what they would have bought themselves. All this time, I also read futuristic articles about electric cars in Popular Science and Popular Mechanics. This seemed like an exciting future, as well as an exciting past, since maybe 110 years ago there were electric cars, but they were gone by the time I was a kid for sure. The first car I owned was a 1965 Mustang. Sorry, GM, but my uncle was a Ford dealer, so we were sort of a Ford family. I personally added Carroll Shelby aftermarket modifications to it: high-rise aluminum manifold, Holley 4-barrel carburetor, free-flow exhaust system and manifolds, and did body stiffening and suspension modifications with the help of some professionals. Over the next 3 decades, I owned mostly a succession of family haulers, not so fast anymore. And over that period, we've seen an amazing improvement in engine efficiency, due primarily, I think, to information technology, electronic control of everything, as well as simulation and optimization of all designs. But despite the 2 major oil shocks we've had during that time and wide publicity about the role of cars in global climate change, most of the increases in engine efficiency have gone to make the cars more powerful, and only secondarily to improve engine efficiency, energy usage rather. As a side note, interestingly, I think today most family sedans would handily outperform my customized Mustang, which is kind of amazing, but they only get modestly better gas mileage. Only during the past decade have we really started to see change with the introduction of hybrids. But even till today, electric cars have remained perpetually futuristic. Well, today that future is finally here with the impending introduction of the Volt, our focus for today. And I think more widely we are on the verge of a really remarkable era of automotive innovation. We have a great panel today to discuss that. We have a chance to learn about what's happening and what's coming from a number of the key innovators in this area. And we'll also hear about the effects, issues, and challenges raised by these technologies. So I'm very pleased to introduce our first speaker, keynote speaker, which is John Gilbert. John is the Executive Vice President and COO for the Rudin organization. Rudin is a very prominent New York developer that has about 10 million feet of commercial space and 18 apartment buildings. Before he was at Rudin Management, Mr. Gilbert was president of the Rent Stabilization Association, and he has served in several capacities for the New York City government agencies. He was appointed one of the initial members of the New York State Real Estate Board. Mr. Gilbert's chaired or co-chaired several task forces on rebuilding telecom infrastructure and security, and serves on Mayor Bloomberg's task forces on energy policy and on improving the city's emergency response and security. He's also on the mayor's new broadband committee. He chairs the New York Building Congress Energy Committee and is an officer of the Grand Central Partnership and a trustee of the New York Hall of Science. He's also involved in the DOE project with ConEd and Columbia, and it's my honor to welcome him to give the keynote. John Gilbert. Thank you.
Good morning, everyone. Happy to be here, and sorry I delayed everyone trying to get up here. I think today is kind of a historic moment because we really are at, I kind of go back to 1892 and the Chicago World's Fair when much of what we see today, and I recommend the book The Devil in the White City that talks about this, but much of what we know as the modern urban city today was first disclosed to the world. It was the battle between Tesla and Edison over alternating and direct current. Tesla won that battle, we think. There's some that think that direct current should be brought back, and that's for a later discussion. It was the moment when Walt Disney's father first saw a Ferris wheel and then ultimately influenced his son to go into the development of amusement parks. It was all about the distribution of water, distribution of electricity, distribution of natural gas. And it's that glimpse, that moment in history that I think we're at right now, because in my own vernacular, I think it's time that Mr. Tesla gets introduced to Mr. Metcalf, and that the creator of alternating electricity, alternating current electricity, gets introduced to the inventor of Ethernet, and that we create interoperability between those two networks so that we truly can begin to influence electrons with photons, and that ultimately off of our BlackBerries and off of our iPhones we truly can ultimately make smart decisions about the purchase of electrons and about the management and of our electricity consumption, and ultimately our footprint of carbon. The discussion today is really about electric cars, and for us as kind of dumb real estate guys, we look at that as how do we make our garages into charging stations. That may sound easy. We just create a bunch of plugs and allow these cars to plug in, but it's actually more fun and more creative than that. Because as we really begin to look at these cars as they're charged and their batteries are charged, that what do we do with that charge if they pull into our garages loaded? Can we transfer that load to the grid? Can those electrons be ultimately distributed elsewhere? And then ultimately, can we program those charging devices to ultimately allow those folks who have pulled into our garages to leave when they want to leave with a full charge? What influences, how does that impact the grid? How does that change the load profiles of the grid on a micro level in terms of that building, but ultimately the overall grid as it's distributed throughout the city? Very, very important questions. And I think it really is that moment. We, in the real estate business, we have been struggling with how do we distribute photons and electrons since the early 90s. And clearly it first was telecommunications. And what we did at Rudin was to say, okay, we're not a telecommunications company, but we have to ultimately enable telecommunication companies to come into our buildings on a carrier-neutral basis and ultimately distribute those photons efficiently through the building. How do you do that? Well, we put in carrier-neutral risers that ultimately allow three things to happen. And this all happened down at 55 Broad Street, and Columbia University was an early partner with us down there. But carrier-neutral vertical risers allow the tenants to get multiple choice of carriers. That's a good thing. It allows the carriers to have a just plug-in infrastructure so they don't have to expend capital dollars. That's a good thing. And ultimately, it allows the building owner to sleep at night knowing that they're never going to have spaghetti in their vertical risers again. That's a very good thing from my standpoint. So ultimately, how do we take those lessons and transform that, forgive the pun, into the electrical grid? And what we see the challenge is, what is the infrastructure that the property owner needs to put into their buildings to allow that interoperability that I touched on vis-a-vis the electrical distribution network and the information technology network, to allow those photons to influence those electrons. And then ultimately, how do we create an environment where applications, once you create that infrastructure, that applications can be derived and developed by smart Columbia engineers so that they can be plugged into that infrastructure that will allow these buildings and our customers to make intelligent decisions in terms of energy consumption management. That is the challenge. And I think it's a wonderful challenge. It starts in the basement where we've got to charge, and in our garages where we've got to charge cars, and it moves right up the riser, right to the very top of the building in terms of ultimately where those electrons flow and whether they're intelligent electrons or whether they're simply dumb electrons. And I think for us, this truly is the exciting part of being involved in ConEd and DOE in terms of the smart grid demonstration program. I believe this will change the world as we know it, not dissimilar to the World's Fair of Chicago in 1892. We will very shortly, and some of us, probably most of us in this room, are getting a glimpse of that right now. And the metaphor that I like to use is a BlackBerry or an iPhone. And if we take that BlackBerry or iPhone and we envision that as a building, that network of within that building, we then can begin to try to develop applications that people will care about, where money can be saved and made, and that ultimately our buildings can be made greener. And the people who work and live in those buildings can be equipped with the tools they need ultimately to make intelligent decisions. So that's our focus. I should end, I could go on for a long time, but I think all of us want to hear what the panel members have to say. I end with a little vignette where, when I first met Robert Metcalfe, the creator of Ethernet, and as we all know Metcalfe's law that the value of any network increases exponentially every time you add another node to that network. It is not a linear equation, it's an exponential equation. And this was back, well, mid-90s, where we had just developed 55 Broad Street, and it was the world's first totally wired work environment, and it was bandwidth to the desktop, and it was a moment of where the internet, now we all take it for granted, right, where it really barely existed. And it was all about that first mile. It was all about, everybody's saying the last mile, and we're saying, no, it's the first mile. The customer is at the beginning of the network, not at the end of the network. And when you think about first mile, last mile, everything changes. So I met Metcalfe and I said, Dr. Metcalfe, I just want you to know that we're going to ultimately see if Metcalfe's law works for real estate. And as we connect each of our buildings with broadband connectivity, and as we put wireless devices on the rooftop that gives us parallel wireless networks that ultimately will survive anything that happens in the manhole or in the street. And as we buy 32 Ave Americas, which was the original AT&T Long Lines building, and transform that building into an infrastructure building that ultimately today is the landing point for all of the data that's coming out of the particle accelerator in CERN, Switzerland, which then connects universities like Columbia and other universities around the United States. Having sat in an audience not unlike this and hearing the head of NYSERNet call 32 Ave Americas the equivalent of the ancient library of Alexandria on steroids because of all of the data that was flowing through that. And Metcalf kind of looked at me and said, yeah, real estate, networks, how's that going for you? And I said, well, we're not out of the woods yet. We haven't figured it out. And it wasn't until I was literally in a meeting with Artie Kressner where it dawned on me that I wasn't looking at the network of real estate deep enough. I was thinking about just buildings and connecting buildings with fiber and microwave antennas. But when you start to think of buildings and the network of those buildings to include every single electrical plug that exists, and to identify or to create an IP address for every one of those electrical outlets, and then surrounding that with middleware and software that ultimately can be so that you can use your mobile device to influence on, off, up, down, whatever's plugged into those plugs, the game changes. Everything changes. So I would challenge everybody here today to think about that and to really think about introducing Nikola Tesla to Robert Metcalf, and to really think about what that means. And then go back to 1892 and try to envision yourself walking into that Chicago World's Fair and seeing all of this for the first time. Everything that we take for granted. The lights, the water, the air conditioning, the heating. None of that existed. And for a moment, envision what that handshake means to each of us as we try to make our cities and our buildings and our homes more efficient, more sustainable, and more valuable, ultimately. So I thank you for the opportunity to come here today, and hope that I've kind of ignited some creative thoughts, and really look forward to the panel. Thank you very much.
Okay, I think at this time we'll ask the panel to come up on the stage and start the next phase of this meeting. Are you going to say some things at the... Shall I do Larry?
Oh, that's good. This is good. Did that right.
Okay, our first speaker on the panel is Lawrence Burns. He is director of the Roundtable on Sustainable Mobility at the Earth Institute of Columbia University. But he has many other roles currently. He's also a visiting research professor in industrial and operational engineering at the University of Michigan. He's senior advisor to the chairman of Hess Corporation. He's a contractor to the National Renewable Energy Laboratory, a member of the Clean Tech Advisory Council of Vantage Point Venture Partners, and a member of the Advisory Council of Green Tech Capital Advisors. Up until last year, he was General Motors Corporate Vice President for Research and Development and for Planning and Strategic Planning, reporting to the CEO and President. And he was a member of the top decision-making bodies for their global operations and products, responsible for advanced technology and product portfolio, capacity and strategic planning. He has been an R&D leader who expanded GM's R&D to a global organization with labs worldwide. And he has championed vehicle electrification, connected vehicles, fuel cells, biofuels, advanced batteries, and many other things, which I think we'll hear about. So please welcome Lawrence Burns.
Thank you very much. Can you hear me okay? I'm hard of hearing. I actually lost my hearing 16 years ago, and so it's important that I come through clearly to you. You know, living in the world of the hard of hearing has its moments. I was at my audiologist recently, and I walked out with 2 other patients, and the woman next to me said, "Isn't it windy?" And the guy next to her said, "No, it's Thursday." and I said, "So am I, let's go get a beer." And speaking of beer, this is 2 facts, if you remember, 2 things from my talk. Golfers, it turns out, a golfer typically walks 900 miles a year and drinks 22 gallons of beer. That's 41 miles per gallon, which is about the efficiency of a plug-in hybrid, of a hybrid electric vehicle, which is pretty good. So here's what I like to talk about. You know, as people who live in the United States, I think we realize we have an enormous amount of freedom to move around and to interact. And it's just essential to our economy, it's essential to our lives, it's essential to creating jobs. And in fact, 90% of our movement is by automobile. There's 250 million automobiles in the United States. They drive on 4 million miles of roads, and we drive them 3 trillion miles a year, refueling them at 170,000 stations. That's pretty daunting, a huge amount of inertia with respect to how we do it. And in fact, the solution that we use is about 120 years old. So, John, I really appreciate your framing comments taking us back to the late 1800s, because that transformation in how we move around occurred at the same time. And the problem we have today is it's not sustainable. It's not sustainable from an energy perspective, from an environmental perspective, but also, very importantly, from a safety and congestion and affordability and equality of access perspective. The good news is that we have a portfolio of technology solutions that are emerging that really promise to address these challenges. But for any of those solutions to matter, they're going to have to scale to an enormously large size to compete with the solutions that we've learned to accept. And for that to happen, the market's going to have to scale it. We're going to have solutions that people really want to buy because the value that they realize exceeds the price that they're paying. And we're going to have solutions that companies really want to supply because the cost that they can supply it at is lower than the price that they can get. And when we can reach that market tipping point with our portfolio of solutions, it's going to take off. And it's going to grow nonlinearly, and it's going to solve these problems. And I'm very excited about that, but we have to keep our eye on consumers first and foremost. Now, consumers of mobility have a wide range of needs. Driving cycles can go from driving around in cities to driving between cities. And duty cycles can go from very light loads to very heavy loads. And we have to accept that there's not one way of moving around. There's a wide number of ways of moving around. In addition, we also have to recognize that we have to get off of our nearly 100% dependence on oil as a source of energy for our mobility systems. The good news here is that biomass and wind and solar, and very importantly natural gas, which are all domestically produced resources that can be deployed at very large scales as alternatives to oil, really hold promise to provide plenty of energy to solve these challenges. But we have to marry up the energy with the vehicle. That codependence is extraordinarily important. Now, beyond energy and propulsion systems, there's also a very important class of technology, and that's connected vehicles. In fact, we're at a point where the historic DNA of the automobile, internal combustion engines and oil and mechanical machines that are controlled hydraulically and mechanically that operate pretty much standalone, that new DNA has emerged. It's electrically driven vehicles using electricity with batteries and hydrogen fuel cells, controlled digitally and electronically, very, very importantly, connected. By connected, I mean vehicles that communicate with each other and communicate with everything along the roadway, communicate with pedestrians and bicyclists. And when we bring these two together and marry it up with what is termed the mobility internet, now this is not just the internet of bits of information or the internet of electrons flowing in a smart grid. This is the internet of atoms moving around and managing that flow of movement. And when we put the mobility internet with that, we really have a way to transform the world. What we're going to be seeing are vehicles that don't crash. They're not going to run into people or bicyclists. What we're going to be seeing are vehicles that can drive themselves. And so texting won't be an issue. In fact, many people would conclude that driving is the distraction rather than texting being the distraction. And then we're going to see the opportunity, because these vehicles don't crash, to reduce their mass significantly. Why is this important? It just simply is not sustainable for our bodies weighing 100 to 200 pounds to be moved around in machines that weigh 3,000 to 4,000 pounds. We have to change that. And one way to change that is to leverage this communications technology so cars don't crash. We get a lot of mass out of the car and change the physics of that whole situation. Now, if you're wondering, is this pie in the sky, I'd like to take you to today's World's Fair, the one that's starting on May 1st in Shanghai, the World Expo. And General Motors and Shanghai Automotive have a pavilion there that will attempt to do much like what we heard about in Chicago. And it's showing a vehicle concept that weighs about 750 pounds. It drives on 2 wheels. It drives autonomously. It doesn't run into each other. And we think the future is within our grasp with that kind of technology. So I'm very, very optimistic about where we're headed. And I'm delighted to be part of the Earth Institute as I embark on my second career. It's great. Both Peniowski and Jeff Sachs reached out to me, and this is just a marvelous campus to be affiliated with, as evidenced by this event. And I just want to end with one advertisement. On Tuesday, we're going to have our first roundtable on sustainable mobility, which is going to begin to focus with working with cutting-edge companies on how we're going to bring this transformation about as quickly as we possibly can. Thank you.
Thank you. And our next speaker is Artie Kressner. By the way, these introductions are long, but these people are very accomplished, so bear with us here. Artie is Director of R&D for power supply at ConEd, and he's responsible for developing and managing R&D for ConEd as well as for Orange and Rockland County Utilities. I've known Artie now for about 6-7 years. He's been really instrumental in the projects that we worked on at Columbia, and has been a real visionary about the area. He manages a program developing technology for electrical transmission, distribution, control center operations, substations, customer operations, and energy efficiency. He's innovated a remarkable number of remarkably innovative projects for ConEdison, which you can see on the wall of his area. He recently co-authored with Roger Anderson, who's speaking soon, Albert Boulanger and John Johnson, a book called Computer-Aided Lean Management for the Energy Industry, on the application of lean management principles to the energy industry. In the interest of time, I will stop there, but please welcome Artie Kressner.
Well, good morning. First, I'd like to thank the organizers of the day for inviting me to be here and to get an opportunity to speak to this group, and especially the students. I think we're into a very exciting time, much like what John described. I think it's one of those pivotal moments. I've been in this business for a long time, and I'd have to say right now is the most exciting, the most interesting, and I think going to be the most significant moment, especially in the energy industry, perhaps since Edison. And that's a lot to say from someone from ConEdison. First, I'd like to set some context. Are my slides on this?
Yeah.
Okay.
Just hit the forward button.
The electric vehicle we see as an integral part of the smart grid. As John described, it's all about the components. It's all about the nodes. And the smart grid is really being driven by a number of changes that are happening kind of simultaneously. There's the emergence of renewable energy in the form of photovoltaics and wind power. It's getting more efficient, lower cost. The problem, though, when you look at the interconnecting large systems, is that it's intermittent and unpredictable. We need to be able to manage this. We need to be able to integrate all of this. Customers that have iPhones and that have all the technology want choices. The just plain vanilla, you could have any color you want as long as it's black, kind of choice just doesn't work anymore. So we need to be able to meet our customers' expectations. Electricity is becoming increasingly vital, both to our personal and economic well-being. I'm bullish on electricity. I think electricity is going to be increasingly more and more vital and important in being able to meet the future that we're all hoping and anticipating. You know, I like to say that people don't buy electricity, they don't buy the product that I've spent my career making and distributing. They really are buying entertainment, comfort, health, security. They're making choices, and by the way, in order to enable those, electricity is an increasingly important part of that. And the next choice that we're going to see being transformed is personal transportation. And these electric vehicles are emerging and are really the enabler of the smart grid. It's the smart grid, each is enabling the other. This is a very vital relationship that exists between all these technologies in the grid. I'd like to borrow from that conversation that John and I had a while ago, the kind of metaphor that John used to describe what's happening. Just as IT has been the fundamental underpinnings of a lot of information technology, has been the underpinnings of a lot of the growth and the innovation, and continues to be, I believe that ET, energy technology, is the underpinnings and growth of the future. Are we ready for the electric vehicle in New York City? Well, first of all, electric transportation is nothing new to New York City. 110 years ago, we had electric delivery trucks parked alongside 15th Street at ConEd, and we have pictures to prove it. So the electric vehicles have been here. But mass transportation right now, the subway, I got here on an electric vehicle. And that's and elevators, vertical transportation, are the backbone of the way we all move around in this city. So to New York City, electric transportation is kind of, we take that for granted. I think that the vehicular traffic in this city, delivery trucks, buses, are a major portion of what's out there. We do have personal vehicles, people do drive, but the principal modes of vehicles that are out in the city are these fleets. And those are ideal for early adopters in electric vehicles. The charging infrastructure to drive those, the length of the trips that those kinds of vehicles take really fit extremely well into this metaphor, and there's a whole lot of them, and they do contribute to the noise and the pollution in our city, and that would be a great solution to have. Also in New York City, those private vehicles are smaller to get into those parking spots that we all hunt for. And they're used by and large for shorter trips, so they make a lot of sense. And from the viewpoint of the grid, I think we are there. I think that for all but a very few hours in the day, in the week, excuse me, in the year, the grid is more than capable of meeting the requirements of the electric vehicles for quite a bit of time into the future. And for those few times that there are issues, I believe there are innovations that some of them we're going to be demonstrating in our smart grid demonstrations that John and Roger will be referring to. And we need to get out of the way and let innovation take place, and people will be coming up with solutions. This is not a problem that's insolvable. I believe it is very solvable. So that pretty much concludes the brief comments that I wanted to fill you in on. Thank you.
Thanks, Artie. Okay, our next speaker is Roger Anderson. I've had the pleasure of working with Roger closely for the last 6 years. He's PI on all the ConEdison and DOE projects that have come out of the center that I run. Roger's been at Columbia for a long time, 35 years. He's a senior scholar at the Center for Computational Learning Systems in SEAS. Roger is also a principal investigator of a group of about 15 people who work on smart grid-related projects in my center. And he's been working closely with ConEd, Boeing, and others for the next generation of smart grid technologies in the city. He was previously at Lamont-Doherty Earth Observatory. He founded a company called Borehole Research, global basins, and did 40 seismic work. Starting the company, I think, the week that oil hit $10 a barrel, which was not good timing. So he came back to Columbia, fortunately for us. He also teaches Planet Earth, which is a science requirement course in Columbia College, and he founded an alternative energy program at the School of International and Public Affairs at Columbia. And finally, he's director of the Urban Utility Center at Polytechnic Institute of New York University. So, Roger.
How many of you know of Energy Star? Everybody knows that. I just wanted to point out that Artie Kressner invented it. He's the originator of it. Bragging on somebody other than myself. Let's see, I need to try to figure out how to get out of this and get to this. Well, I'd like to build on what the first two speakers have been talking about in terms of trying to understand the complexity of this machine that we are about to launch into. In 1897, the concept was pretty simple. Electricity flows from the generation downhill until it gets unimpeded to its customers, basically like water sloshes downhill through rivers to the ocean. We're in a fundamental recharacterization of that pathway, and electric vehicles are one of the major drivers, along with getting out of this hydrocarbon economy and more to what I like to call the electric economy. Electric vehicles are mobile, and they carry the load with them, and consequently they and other sources that are distributed, like batteries, large batteries, for example, that stand alone from vehicles, change the dynamics of management of the grid. The electric grid now will have to have the capability of receiving power and distributing power on all ends. It's not a first adapter or a last adapter, or the first mile or last mile, it's every mile. And that is a very interesting computational problem, first of all, and it's an extremely interesting control problem. And if we are not careful, it could be a god-awful mess. I think that the thing that is driving us here at Columbia so hard to participate in the reformulation of the electric grid in New York to what we call the smart grid is the worry that if we're not careful, the lights are not going to reliably come on when we flip the switch, and John Gilbert's elevators are not going to routinely move up and down when you push the button and the little light comes on. If we screw this up, we screw up the global economy. It's sort of like launching into Wall Street that we just experienced in the electric grid. And we don't want to do that. We're not capable of throwing the dice in this kind of a world and hoping that we can cope with the complexity. It's a nonlinear dynamic machine, the world's most important machine. And if we ask what are the problems that we have to address? I just have a few of them that have impacted Columbia in particular. The machine is like a complex family of patients. And we, in fact, use here at Columbia Technologies right out of our drug treatment and medical profession. There are pieces of it failing all day, every day. Components of it, just like people have knee injuries and have to have heart checkups and all of these things. And when you have a dumb machine, one where everything is just flowing, sloshing around like we had maybe up to about 10 years ago, you overtreat that patient because you can't tolerate the failures, because as you well know, in the electric grid, people get hurt. And so we have to introduce the intelligence in this kind of a system in order to control not only the complexity of it, but the fact that it's constantly failing. It's like the B-52. Everybody knows the plane built in the 1950s still flies. Every one of those planes has 0 components from 1950. They've been rebuilt and rebuilt and rebuilt. Modern engines, modern control systems. That's how they stay up in the air. The electric grid is very similar to that. While there are still some components of it that Thomas Edison himself laid in the ground in the streets of New York City, there's not a lot of those components. And every year we introduce more copper than we really have to be able to afford in the city. As Artie also likes to say, it's the largest copper mine in the world right here underground in New York. Introduce into that 1 million cars that are electric. And we really have to get our act together about how to charge them, how to discharge them. They're all going to travel into Manhattan in the morning. They're all going to plug in and move into John's, from his apartment buildings to his office buildings. And at night, they're going to go back down into the green garages in the basement, and they're going to go to the suburbs, transferring this massive load of electricity that we are just now figuring out how to handle in an intelligent, computer-controlled, systematic way. That's what I want to say.
Thanks. Thanks, Roger. Our next speaker is Jeffrey Sachs. Probably most of you know him, one of the most visible faces of Columbia. Jeffrey is director of the Earth Institute. He's Quetelet Professor of Sustainable Development and Professor of Health Policy and Management at Columbia. He's also been special advisor to, he is special advisor to United Nations Secretary General Ban Ki-moon, and was advisor to Kofi Annan before that on Millennial Development Goals and international agreed goals to reduce poverty, disease, and hunger by the year 2015. He's also president and co-founder of the Millennium Promise Alliance, which is a nonprofit organization aimed at ending extreme global poverty. In 2004 and 5, he was named among the 100 most influential leaders in the world by Time magazine. Sorry, Newsweek. He was awarded the Padma Bhushan, a high civilian honor bestowed by the Indian government in 2007. He's a member of the Institute of Medicine and is a research associate of the National Bureau of Economic Research. Before Columbia, he was at Harvard for 20 years. Last but not least, I should say I enjoy reading his Scientific American columns. Thank you. So, Jeffrey.
Thank you very much. It's really a pleasure for me to be on this podium, and I'm here trying to soak up as much of the wisdom as I can from this remarkable group, because my little niche in this is to try to figure out how public policy might help this process along. If this were mainly a matter of a thrilling technology on its own time rolling out I think we would feel very confident that we're going to get to where we need to get with a very exciting new range of opportunities for all of us here in New York and for humanity. But the problem is that we're operating against some very, very serious timelines that are a great threat. And what we're talking about here not only should happen, but actually has to happen a lot faster than such a complex process would normally occur. And that's why I'm listening to try to understand if and how public policy can nudge this along with some alacrity and some sense of urgency. Now, I know, given the complexity of all of this, that there are certain things that can't be forced. And Larry Burns is educating me on the generations of technology that will be needed to reach certain of the crucial tipping points that he spoke about. But let me talk briefly about a couple of the other tipping points that we face on the planet to frame some of the importance of what we're talking about today. Because, of course, we're talking about not only the excitement of new technological possibilities, but we're also talking about heading off some extraordinarily dire risks that the planet faces. The transport sector is roughly around a quarter of the contribution of anthropogenic greenhouse gases that are driving global climate change. And while we're all buffeted daily by doubts of climate science and by skepticism and by messages not to worry, and while we're in a strange public environment in which more than half of the American people don't believe this is a challenge, we at Columbia are very lucky to be part of an extraordinarily rich scientific environment, science environment of the world's leaders in climate science. And I can tell you what we hear every single day is that this is a world changer and we're just on the cusp of disaster. Our leading climate scientists, James Hansen, who is the US government's lead climate scientist at the Goddard Institute of Space Studies, which is at 113th and Broadway, and our guru, Wally Broker, at the Lamont-Doherty Earth Observatory, both in their very distinctive ways, one from the atmospheric side and the other from the ocean side, and both from the paleoclimate record, carry one fundamental message, which is that the climate system is profoundly unstable, nonlinear, subject to tipping points, and that by all accounts of the paleoclimate record as well as the physical modeling of the climate systems, as well as what our ecologists and agronomists tell us about actually observed climate behavior in recent decades, we're very, very close to highly nonlinear and highly dangerous changes in the Earth's environment. So what we're talking about here is one crucial component of addressing that problem, because the ability to move the at least the light-duty transport fleet around the world, which itself will grow phenomenally in the future years as China becomes the world's largest market, as India's Tata Nano at $2,500 sets a new price point and leads to tens and then hundreds of millions more vehicles on the road. The challenge of finding a way to benefit from personal mobility but in an environmentally sound manner is one of the greatest challenges that we face in the world, and the possibility that electric vehicles open up not only a new vista of the quality of life, but also a new vista of energy systems that are both environmentally safe and plentiful is extraordinarily important. Of course, we're facing another somewhat unknown threat, but one that is obviously significant, and that's the availability of conventional oil, which, as Larry Burns said, and of course, as everybody knows, is the overwhelming energy source for the world's light-duty fleet. And I think that it is fair to say that while the debates about whether peak oil has arrived or will arrive in 10 years or will arrive in 20 years or will arrive in 50 years is a real debate with a lot of unknowns, the security and availability issues of our conventional petroleum is a huge question right now. And I would argue that we're enmeshed in war over that very question, a very stupid war in my view, but a kind of conflict that we're going to see more of, unfortunately, unless we also find a way to fundamentally alter our energy system. So it seems to me that we're talking about something here which is extraordinarily time sensitive, but also extraordinarily complex. We're aiming to address a quality of life issue that will be of importance for well over half the planet very soon, which is the well over half the planet living in the cities. We are addressing a environmental security issue of profound significance. And I think we're also addressing indirectly a national security and a global security issue, and that is how does a world economy that's already pressing very hard against the natural resource base, and in my view has already lifted the real price of oil by a factor of roughly 3 during the past 10 years, and I think it's likely to stay high and continue to rise. How do we face these challenges? There's also a national technological challenge, which is the very real point that we're in some crisis in our industrial and manufacturing base in this country. We are delighted to see GM on the mend, but we're counting on the Chevy Volt to be the kind of new leadership that can allow our national industry also to play a very significant competitive role in the world in the years ahead. And time is very sensitive on that as well, because our national economy, in my view, is in crisis, not just a financial crisis, but a technological challenge, let's say, that is a challenge of a much more competitive world than we faced even 10 or 15 years ago, because our competition's coming from all sides right now. So to my mind, the issue here that I'm trying to understand as a policy analyst and advisor is the timing. What are we capable of achieving in transformation to reach scales that will make a measurable difference on all 3 of these dimensions, on the environmental security, on the energy security, on the national security, I would say, is the second, and on the technological leadership. If we go along at the pace we're going purely by market forces alone, my view is that this will remain, as many people predict, very important, very fascinating, very exciting, but from a scale point of view, a relatively small part of a much larger and quite dangerous story. So I believe that we're in the business not only of trying to find how to make all of these complementary systems work, but do it in real time and do it in accelerated time, in policy time. Now, I just testified in Congress last week on these issues, and we're thrilled, by the way, with our, we were represented by the former head of the Ways and Means Committee, who's temporarily stepped aside, and the new one is our good friend and good friend of this industry, Sandy Levin, who called these hearings. But I can say what I already knew beforehand, and after listening to the rest of the committee knew very well after, we have no national policy on these issues at all. We have some important components where the government is financing some technology in batteries, is looking for and providing some incentives for the new vehicles, and is definitely interested in these issues. But to my mind, we do not have a proper framework yet that addresses the realities of the technological complexity, the role of public policy, the role of infrastructure, the role of energy policy, the role of consumer realities, and the role of the time dimension that is involved in many of the pre-commercial and complex complementary aspects of this challenge. The administration, president said that he wanted a million electric vehicles on the road by 2015. Good and specific goal. We don't yet have a policy to achieve a goal like that, or to, and we've not stated I'd say yet, a serious and national way what kind of goals we should have for 2015, for 2020, 2025, 2030, and how we would get there. We also have the complexity of the international climate negotiations, because it should be absolutely clear to everybody that no matter what the United States does on this, unless there is a global framework for climate change, the world's going to be wrecked. And it's going to be wrecked within the next 40 or 50 years, and that means that we need to take action now, because we're talking about infrastructure and technologies that are going to already be set in course for decades to come. And so the issues of the electric vehicles are partly a national competition issue, but they're also partly a global survival issue as well. That makes this very hard. What is our international policy perspective on what we're talking about, on the ways that systems design, sharing of technologies, shared concepts, global goals, global standards should get integrated? As you all know, and I know it very well sitting inside the UN, our international negotiations are in disarray on all of these issues. One of the main reasons they're in disarray, unfortunately, is there is a complete disjunction between the diplomacy of negotiations, the engineering realities, and the private sector. It's as if it's three completely different worlds. And so one of the things that also needs to be done is to bring these worlds of the negotiators, the companies, and the technology experts together. So all of this is to say that I'm listening from a very particular point of view to the discussion. This is an extraordinarily complex system of systems that we're talking about. I think everybody made that clear. It is also, and I share the view, for all of the important reasons, both what is potential in the technology for new quality of life, what is needed for the environment, and what is needed for global security and energy availability, we are at a historic juncture. We really are entering a new era. But it's not just entering the new era, it's not just being pointed in the right direction, it's getting to some real destinations in time to make the difference that we're going to need. Thanks.
Thanks, Jeffrey. I've been told we're running quite late, so despite his many achievements, I'm going to shorten Tony Posawatz's introduction. He currently, we finally get to the Volt, right, as the centerpiece. Tony serves as the vehicle line director for the Chevrolet Volt. He's been at GM for 25 years. He's really pushed this from day one. I think he was employee number one working on the Volt. And it's been brought to market in a pretty quick manner. He's co-chairman of the Electric Drive Transportation Association, and was responsible for other vehicles like the Cadillac Escalade and Chevrolet Avalanche. So, Tony.
Welcome.
Thank you so much. I want to first thank Columbia University and their affiliated partners for organizing such an event. For some of us in the corporate world, it's truly invigorating to leave the offices, the PowerPoint presentations, and be in such a vital campus environment. And so thank you so much for that. It's good for the soul. As was stated, my name is Tony Posawatz. Sounds like kilowatts, but pronounced Posawatz. And it is true, I do have an Earth Day birthday. So it was fate that I be destined, and Dr. Burns is one of the people that helped influence my appointment into the position of the Vehicle Line Director for the Chevy Volt. So it is all coming together, I think. I will talk a little bit about the Volt today, but I want to first acknowledge and recognize my fellow panelists. I've learned a lot from them historically. I've learned a lot from them already today, but I will differ with them on a few things here. Notice the man from the General Motors Company did not bring any PowerPoint charts. I brought a real drivable car that's out at College Walk, and it will be there out till 1 o'clock today. So if we do get the opportunity, please enjoy some of the sunshine of Earth Week. I like how it's changed from Earth Day to Earth Week. Enjoy that. Take a look at the car. We've got some technical experts there, and I'll tell you a little bit more about the story of how and when the car is coming, and it is coming. The other ways I differ with my panelists is the following. Notice the man from General Motors Company is the one without the tie. I have a short sleeve shirt underneath here. I don't even have a t-shirt on. It's part of my mass reduction program to be more efficient. Had I only got a haircut before I came here. But I think the comments from the panelists were really wonderful setup. It gives you context about this unique moment in history that we're upon us. And let me comment a little bit on an additional point in the time frame that was illuminated by our keynote speaker. And I used the term illumination on purpose. Recently had an opportunity to meet and spend some time with Daniel Yergin, who many of you know is an esteemed author, Pulitzer Prize for The Prize. And so I read it intently, trying to learn about energy, some of the history where we came from. I've done the same with the history of electric vehicles, and I think some of our panelists highlighted some of the long, rich history of electric vehicles. Interestingly enough, in the prize, there's a fascinating quote from Winston Churchill. And it was really what spurred on Daniel Yergin to call the book The Prize. And it was something to do with when Churchill was the head of the Navy in the UK, and he had determined what fuel he was going to use to win his battles. He chose petroleum, and he used the term or the phrase, mastery itself is the prize of this venture. We've used that a little bit internally on the Chevy Volt team to say technological leadership and the ability to use technology and innovation to solve our problems is really what we're all about. And as identified by Dr. Burns and Dr. Sachs, this is a very, very complicated problem. But we have history on how we've worked together and solved problems like this. If you go back to the day and age when the oil industry first began, it wasn't gasoline that fueled its growth, it was kerosene. It was touted as the new light. It created the ability for people to read, to become educated, so on and so forth. We remember the oil wells in Pennsylvania. It was kerosene that was first the product, not gasoline. Interestingly enough, innovators and inventors came up with something. And we've got wonderful colleagues with rich experience in how the grid came to be, how Thomas Edison created the incandescent light bulb and truly created the new light, replacing kerosene. And kerosene, just like gasoline, also had its baggage. There was many a small hut that was burned down and the like. Dr. Sachs and I have talked about some of these opportunities that some of this innovation and technology could bring to bear. So I thought that context was helpful because I think it's a very unique opportunity, as stated by my fellow panelists, on bringing so many interesting winds of change together, and they intersect. Dr. Burns has commented to me many times about something called the power of and. So let's comment a little bit about 6 technologies that are just really gaining momentum, but the synergistic effect of having them work together is even more powerful. And I'll cite some examples with the Volt and connecting it to the smart grid as well. The technologies that are absolutely fascinating are obviously electric propulsion, and all that goes with that. Motors, power electronics, systems thinking, integration, software to move these vehicles. Advanced batteries. The Chevy Volt battery will take what we typically know as the lithium-ion cells in your cell phones. I would venture to guess most of those cell phones batteries probably don't last more than a year or two. Yet, with the Volt, we will accelerate the robustness of the design and we'll create a battery pack that will last 10 plus years in a car and perhaps another 10 years outside of the car. Talk about a leapfrog in the basic, simple cell that you find in your devices and operating in an environment, mind you, with temperature changes, severe, dramatic humidity, vibration, one of the harshest environments that exists. So we think that this is a significant technology. We're taking a leadership position on it with the Volt, and eventually we'll understand a little bit more about the power of and intersection, how that helps some of the other key technologies I referenced. Technology number 3, renewable energy sources. If we only could predict when the wind blows and the sun shines, then we could be waiting there with our collectors, right? When the Chevy Volt battery is plugged in, hopefully 22, 23 hours a day, it becomes the ideal collector. Most people are not driving at night, although I've had some strange hours here in the last couple of weeks that have caused me to do that. But nonetheless, that's when the wind blows. When you're at work during the day, the infrastructure opportunity that exists to collect the sun, if you're just plugged in. And I know the people on this campus are plugged in, and we're going to get you even more plugged in as we go forward. And we talk about the future and when the Volt is coming to market. Smart grid, technology number 4. It was well stated by some of my colleagues how important this is to eliminate waste from the system. And so much waste does exist. And we'll talk about how we can make that a reality. 5th technology, spoken to by Dr. Burns, the connected car and how our lives are connected. I have a fun thing that I do every time I'm on an airplane, and I sometimes chat with the person next to me. I've been known as someone who engages in discussion and conversations, and I will place a bet on them as to how many seconds it takes a number of people that sit in front of us in the plane when the plane lands to turn their devices on to get reconnected. It's a very, very powerful concept. Why can't we now connect our cars to our devices, to our grids, to our lifestyle? We have the technology to do that. Finally, 6th key technology of really fascinating interest to me is also the engineered fuel space, whether that be biofuel or some other way to integrate new fuels and some of the wonderful innovations and inventions that are occurring there. So amongst these 6 technologies, multiple intersection points. Let me comment only on a couple of them with respect to all of your time. And let me highlight a feature that General Motors has as it relates to one of the fundamental strong pipelines using cellular technology, and this is our Onstar wireless telematics platform. Something that many of you are familiar with. We've had it in our cars for the past 14 years. The Volt will get the 9th generation black box of Onstar in it. And what does this allow us to do? It certainly allows us to unlock and lock our cars remotely. It allows us to deploy airbags. It allows us to connect with a safety advisor. It allows us to do a host of other things under the fundamental guise of safety and security. Now recently, I had an opportunity to go to the Onstar Command and Control Center at our Renaissance Center in Detroit, Michigan, and watch live the capability of Onstar applied to the next level. What does this mean? We now have the ability not just to remotely unlock and lock your car. We now have the opportunity, when we're advised of a theft of your car and the right authorities are involved, that we can literally prevent a high-speed chase, locate that car, and safely and securely depower that car so that that criminal can be apprehended by the authorities. So I was watching a video of this, and the thing that I found most intriguing at the end is as the policeman approaches the car, there's obviously no power, he can't move, he can't escape. He tries to open the door. Conveniently, the door is locked on him. He tries escaping from the sunroof, and we close that escape hatch as well. So, what does that tell us as it relates to the various technology circles and the intersections? If we can stop a car from driving safely and securely, I think we can send a signal to stop charging if necessary, if we're at a point in time in the middle of August at 3 in the afternoon when we need to shed some load as it relates to this technology. And that just gives you a glimpse of the possibilities. Similarly, as we collect data from Onstar, from the car, we have a battery doctor on board. We'll be collecting more data, just like some of our friends on the internet collect data and try to understand what advertisements you should be sent and so on and so forth. Data is powerful, and in a university such as Columbia, I think you know and all understand this. So it's a very, very exciting time when you think that we do have the technological pieces, we do have the problem solvers to connect these dots, to connect the nodes, as was stated earlier. I think that's very exciting. So it would be remiss on my part if I didn't at least finish with a shameless advertisement for the Volt. And I know you would expect that, so please indulge me. Chevy Volt is here today, and we've been driving it around and engaging many a customer in the product for the last 6 months or so. Very, very unusual for a conventional car, let alone a car that is so advanced. The car is being built today as we speak in production flavors. And what does that mean? It means the production version of the car is at its home plant. There are production parts off of production tools being assembled to ready this car for the market to be launched at the end of this year. As you know, it's been a well-publicized project, and our launch date has been advertised as November 2010 is when we will build retail cars. Between now and then, we will have demonstrations, and we will squeeze out every possible issue and bug that we can so that this car can be ready for the market, and it can be your everyday primary vehicle and be the first mass market electric vehicle. And hopefully be an enabler for a host of other electrically driven vehicles, whether they be pure battery electric vehicles, fuel cell vehicles, and be one of the great integrators of all these technologies. So I'm sure you are rooting for us, wishing us luck. We feel we're on a very, very good glide path to deliver this. Final thoughts are, since the theme of this conference is New York and the electric car, we would very much like to be bringing this car to the Big Apple, to the surrounding area. We have a DOE project with ConEdison, so they will be receiving some of the very first cars later this year and helping us make the car seamlessly interact with the grid, the new fueling station. And I don't know about you, but I really look forward to the day where my gas station will be in my garage and I'll be gassing up my car in my pajamas when I'm sleeping. I really look forward to that day, and it's not far off. So I very much look forward to working with you in the future. I do believe that your region and area is organizing itself to be plug-in ready. The EVs are coming, the Chevy Volt is coming, and thank you for your time.
Thanks very much, Tony. Okay, at this point, I'm going to introduce Kathleen Deveny, who will then take over for the rest of the event. Kathleen is the Deputy Editor and Global Business Editor of Newsweek magazine, and she oversees the business and economics technology coverage of Newsweek, including especially the Green Rankings franchise for the magazine, which she created as an annual ranking of the 500 largest U.S. companies. She had worked previously at the Wall Street Journal and before that at Business Week magazine, and I'll keep it short, but Kathleen, welcome.
Thank you very much. I'm going to make a few comments, and then I'm going to ask our distinguished panelists a few questions for each of you, and then I'll throw out a few questions for the whole group, and then I'm hoping that you in the audience will have some questions that you would like to put to our panelists. Anyway, I think we all know that New York is a very unique transportation market. For instance, how many people drove here today in their own car? Anybody? Okay, cameraman, good. Which is not to say that New Yorkers don't have cars or don't drive. About 40% of us own cars, but we drive differently than people in the rest of the country. And I don't mean more recklessly, I mean different times. We tend to drive on the weekends more. There are very different patterns based on which borough you live in. So people here are driving, but it's a different place in many ways. Okay, I'm going to keep talking. We garage our cars differently. Most New Yorkers park on the street or in commercial garages. We don't have our own garages for the most part, all of which presents kind of unique challenges, but also opportunities for electric vehicles in this amazing market. But there's also a great need, because just like the overall figure, transportation emissions account for about 22% of total New York greenhouse gas emissions. And electronic vehicles represent a very clear and obvious way to reduce those and to help the city meet its overall sustainability goals. So even in New York, where we think of ourselves not driving that much, we have as much work to do as the rest of the world does in reducing those emissions. Now, there's already a pretty large group of New Yorkers who are ready and willing to embrace electric vehicles, according to a pretty recent study by the Bloomberg administration. Up to 16% of vehicle owners say that they're ready today to change their behavior, start driving electric vehicles as soon as they're available, which is a pretty large group. And as Tony said, next fall we'll have the opportunity to actually buy some commercial vehicles and start driving around. So I want to talk to our panelists today about whether New York is really ready for the electric car and what do we have to do to get started on that. So I'm going to start with Larry. You talked very persuasively about why we need electric vehicles. Do we want electric vehicles? Is consumer demand there? Are we ready?
Well, that's a great question, because if consumers don't want them, the technology won't scale, and we're not going to solve the problems. What's so exciting about the Volt, and quite honestly 29 other electric vehicles that are going to come to market in the next 18 to 24 months.
29, you said?
30 in total will be coming to market over the next 2 years. What we're going to be able to learn is what the consumers really want. Technology doesn't happen in the auto industry in one step. Typically, it takes 3 commercial learning cycles. A commercial learning cycle is the product in the hands of real customers, made with parts manufactured by real suppliers.
Right.
Tony said something real important. The Volt's now being produced with production parts that were built with production tools.
Right.
Hugely important step. And so we go through 3 cycles, and we're going to learn what customers really want, and we're going to understand what suppliers can really deliver, and that probably will mature at about the year 2020. Right. So I think there are customers who are ready, and they're going to be our NASA astronauts for this initial mission. We're going to learn from them, and then we're going to get more customers, and then the thing will tip, and that's what we have to drive toward.
What do you think is the biggest psychological barrier to getting people into this kind of car?
Range anxiety, and that's why concepts like the Volt and the Fisker Karma are so important, because they've taken that off the table.
Right.
That's not to say some of these other electric vehicles won't have important learning opportunities that do not have range extenders, but a customer simply doesn't want to make a trade-off on convenience and safety and security and the use of their time.
Right.
And so if suddenly you're inconvenienced because you don't have enough range, or you're concerned that you're going to be stranded somewhere and you're going to have to wait to plug your car in, that's just a real customer concern.
Right.
So
even more so than price of the vehicle, do you think?
Well, that's another important issue. The cost will come down over time, and the U.S. government's playing an important role to provide tax incentives to get this started. The lithium-ion battery has the potential to reach a cost target of about $200 to $250 per kilowatt hour, and we're going to have to take the number of kilowatt hours down. The Volt has 16 kilowatt hours, and we're going to have to take that cost of the battery today, which is significantly higher than the 250, but we'll do that by learning. And so we have to stick with this. I mean, I'll be very disappointed if the story is told based totally on first reactions, either overly positive or overly negative.
Right. If we're launching an entirely new dynamic, we have to give it a little bit of time.
Yeah, we've got to stick with this, we have to learn.
Artie, it's a beautiful day today. Kind of hard to imagine August right now, but what about that hot August day at 3 o'clock in the afternoon? What do we need to do to make sure that our grid is stable enough at that point to support the additional energy we'll need for electric vehicles?
Well, at those relatively few hours of the year, days of the year,
Right.
I think that there are technologies. We just heard about one that Onstar is developing. So I'm optimistic that those hurdles are very solvable. And the integration of information with energy as the smart grid is developed will alleviate that problem. So I don't see that as a showstopper.
Okay.
And definitely not.
So we're ready now.
We're ready now, especially in the early years. We just were hearing about the cycles of introduction of products.
Right.
That's going to take some time. And
So you're saying additional demand will ramp up slowly?
will ramp up relatively slowly.
Right.
And that learning experience on the vehicles is equally important in terms of the learning experience on the grid and being able to match this demand. It's not like we haven't seen the introduction of new technologies before.
Right.
There's the introduction of computer technology and the implications it's had on energy growth and use.
Of course.
The air conditioning in the 50s and 60s, and the electrification of the kitchen in the
I know
30s
that's
and
Tony's
40s.
big example.
So that this is I think something that our industry has seen before and has responded, and that's going to be our challenge.
Right. Well, as one of the 40% of New Yorkers who do own a car, where do I plug my electric vehicle in? Do we need public charging stations? And if so, who's going to be in charge of building them and maintaining them?
Yes, I think that we by and large do need charging stations, and John Gilbert mentioned one of the opportunities he sees in his buildings is providing charging infrastructure, and I think that this is again an opportunity, an economic opportunity, business opportunity for many people to differentiate their services, to create new services, to create value in different ways in garages, and even in some public spaces.
Okay, great. Roger, we're talking about marrying together some extremely complex systems across many disciplines. What about the human capital aspect of this? Are we training the right kind of engineers? Do we need to think about how engineers are trained differently?
Absolutely, yes. The system of systems requires a system of systems engineers. And that does not sit easily within silos of traditional departments. And the talent will probably drive this. On the campus here at Columbia, the most active and most innovative energy group is led totally by the students. In fact, they're about the only ones who've gotten SEPA, the School of International Public Affairs, to talk to the engineering school, to talk to the Earth Institute. Sorry. They're the ones who are in all of these organizations. And I believe that the force will come from students who want to do this for a living.
Right.
It's like the early days of the flower generation, right? I don't know what we'll call it. We're running out of letters, X, Y, Z generation.
But we need a new kind of engineer, basically.
We need a much broader, more across-the-board trained engineer than a specialist.
Okay, so when we have those engineers and we're working on the next generation of the smart grid, have we made the kind of capital investment that we need to move on to the next level?
Well, I've been talking around the country for a group of, it seems to be being led by universities. I've been over to Arizona State and to Rice and talking to them about what we do after the stimulus money runs out. So the smart grid is putting a lot of money into New York City, $370 million, the largest investment by the federal government in any city in America. But what happens after 3 years? We fundamentally believe there won't be a follow-up from the feds.
You do not believe there'll be a follow-up?
No. Stimulus money is an extra appropriation, and it's doubtful that commitment can be continued by, say, Department of Energy, for instance. And so it's really in our court. Philanthropy plus academia plus industry. And to sustain this over the 20 to 30 years it will take to put 1 million electric vehicles into New York City. That's what Jeff's talking about. The big challenge, I believe, is probably one of a government policy rather than technology.
Right, and as he was saying also, it's a place where you have to bring the negotiators together, so.
I just wanted to add, I was once told an engineer is a person who likes to work with numbers but doesn't have the personality to be an accountant.
Accountant,
and, But from my own experience, there is nothing more interesting than what we're working on right now.
Right.
And we have to go beyond it being interesting. We have to get it over the goal line. We have to scale it in the marketplace. But this is really exciting
This
stuff.
really could be truly a disruptive technology, as we were saying.
And the opportunities are at the interfaces, and that's why we need the systems of systems perspectives. And I think the engineers are going to lead us to the solution. I really do.
Okay. Jeffrey, specifically when you're talking about New York City, if you can bring it down to that kind of scale, what kind of health benefits can we see right away from converting to electric cars? Or more to the point, what level of kind of penetration do we need to see before we start realizing some health benefits?
That's a tough question. You know,
I saved the hardest one for you.
Yeah,
sorry.
well, I mean, and I'm not qualified to give a thorough answer to that in any way. Clearly, what we're talking about here is not only the vehicle, but what happens, and not just the grid, but how the energy is produced, what that means for air quality, also for public safety, as Larry was talking about, how the cars actually drive and what happens to the traffic flow. So from a public health point of view, there are many aspects of this. There's the energy aspects, there's the traffic safety aspects, and so forth. I think one of the things we haven't really talked about enough, talked about how the grid can be managed. We haven't talked about the challenge for New York and nationally for what kinds of energy we really are going to be putting into the grid.
Right.
And here, the problem is pretty serious in the sense that all these wonderful alternatives, which we all want, all have their own complex problems around them. We've not yet, and I'm not up to date on this, but it's been very hard to get agreement of communities to put in upgraded grid infrastructure, for example, to carry renewables on direct current. Because of bigger towers and communities not wanting the grid to pass through their area. We've had a difficulty with getting even a first demonstration project of carbon capture and sequestration, which is another way to clean up the grid. There's a proposed project in Jamestown, New York, and the community says, we love this technology, could you do it 5,000 miles away, find out how it works.
Right.
And then after a few demonstrations, we'll have it here. So I'm pretty impressed about the fact that we have so many complex pieces to this that we've not really focused on. I knew, we all know about NIMBY, and we all have come to learn about NUMBY, not under my backyard with carbon capture, but I had not heard until last week Banana, which everybody probably knows, but it built absolutely nothing anywhere, anytime.
Well, we are familiar with that in New York. So.
The number of projects that are now delayed on every kind of power plant, every kind of grid facility in our country is very, very large. So it's true in New York State. It's true nationally, and this is where I think the political leadership will be key to breaking through some of these barriers.
Right. Let me just step back and go global for a second. What is the role of EVs in global development and sustainability? Is this something that we're going to see being adapted in developing markets in different ways, or do you think it's something that the United States will pioneer?
Oh, I think this is an incredibly important issue because, first of all, the world is now more than half urban to begin with, so we're talking about, at least at the beginning, an urban technology that is going to find a need all over the world. the world's biggest cities, by and large, are going to be in the developing countries in the future, almost all the mega cities. Third, these cities are building out their infrastructure for the first time in many cases. That's the opportunity to get on a path that makes sense. And of course, we are seeing, we've seen this year China overtake the US as the world's largest automobile market. Right. And I think we'll never see the US overtake China again, because that's a market that is subject to phenomenal growth. Although it's such a crowded country, it really poses a lot of questions about what kind of automobile penetration in the long term. All the experts here would know better than I, but in any event, these issues are absolutely of fundamental significance to the developing world, which is going to be the place where most of the automobiles in the future are sold, because that's where 5/6 of humanity lives right now. And so any leader that one talks to these days, recently spoke to the president of Mexico about this, and he's asking, well, what about Mexico City as a place to get started? It's a city of 20 million people with major environmental challenges and extreme interest in this. But you think about China, India, Brazil, this issue is an absolute global issue, and we're going to face global competition, no question about it, on who's actually going to come up with the models.
Right, right. Great, thank you. Tony, we've established, I think, in earlier conversations and listening to the comments that range anxiety is a big issue for consumers. So how do I know when I'm on the Taconic that my Volt isn't going to run out of power?
Great question, and it's been something that was referenced previously that has been an anchor around the technology for a long time. Certain characteristics of battery technology, and one of the reasons General Motors embarked on the Chevy Volt is we felt the lithium-ion technology and family of chemistries was a nice point to build off of because of it was increased power and energy density. So it's been a problem for electric vehicles for the last 110 years. Now, many people are offering different solutions for extending the range. Because frankly, as much as we hear about many customers wanting to be green, right, the green in their wallet is still dictating their actions and behaviors. As such, one of the ways that we've constructed the Volt architecture, the propulsion system architecture and the like, is so that it can create a solution to the range anxiety exists with batteries that we know of today. There are ways to increase this range phenomenon. There are multiple opportunities for charging. You can go into faster charging. You can go into maybe changing out your battery. You can go into different ways to create electricity on board the vehicle, right, to extend your range. The really key point was, from our perspective at General Motors, is that until you solve the issue of range anxiety, you would never be able to make an electric drive vehicle mass market, because customers do not want to make the compromises. Right. There have been electric vehicles for so many years, so many different attempts and efforts, and I'm not sure what the largest single volume was, but for example, the Tesla, certainly it's price prohibitive for many people. I'm not sure if they've hit their 1,000th unit yet. Or if they'll ever go much more. And I recently read that the Roadster will, at some point in time, move on to another product, move on to another line, if you will. And it gets to Larry's point about the generations of learning, right, and technology and probing the market and understanding. The one thing I can say is that I have suffered from range anxiety before. As part of the new GM, I think we try to spend more time driving electric vehicles, not just our own, right, but others. I've driven the Mini E here in Manhattan before, and I've not been able to connect with a friend because he was worried he wouldn't get back to White Plains. And said we actually met in Columbia versus down on the stock exchange, in a host of different vehicles. So I think, kind of to the points made by the other panelists, it has to be consumer focused, right, it has to be sustainable from a business perspective, and you have to have a model to get there. And I think there are some nice innovative technologies and choices out there. We believe the extended range feature on the Volt today.
Tell us about the range of the Volt and what that
Absolutely.
is.
Right now, we have high confidence that the Volt will provide up to 40 miles for most customers. And this is completely on power from the grid stored in your battery. Seamlessly, if your battery gets to a point where you've consumed the amount of kilowatt energy available for use, that are usable for the battery to drive your 40 miles, we seamlessly turn on an engine generator set, and we can go without refueling or stopping an additional 300 miles. And so as Dr. Burns indicated, you now have the choice of close to 170,000 fueling stations, or I don't know how many millions of plugs there are, but I gotta believe there's quite a few. The Volt was also designed based on the size of its pack that you can overnight with a simple portable cord set, a 120 volt cord set. We call it an EVSE for the engineering students out there, electric vehicle supply equipment. Write it down, learn about it. It's going to be an important connector umbilical cord, as I referenced, from the transportation sector to our friends in the utility sector. We can charge that vehicle without special equipment or apparatus overnight, 8 hours when you're sleeping. With a 240 volt, dropping your dryer outlet, if you will, it's about a 3-hour charge. And we're going to anticipate people will get as many charges in as possible, hopefully at your office or at your university and the like. Dr. Sachs, I think you have some influence. You can get a few charging stations. Okay. And so the concept of range anxiety is real. We have some solutions, we think. And I think in the future, other technologies will emerge, whether it be battery or otherwise. And I think it's just the most exciting time. But I do really want to emphasize that the range anxiety concept is real. And if you look at the sort of the behavior from people, if you know you only had 100 miles of range, you think that people are driving 80, 90 miles? No, they cut it in half. If you have variation around that range as it relates to temperature, that decreases it more. And if the car becomes not usable or not usable in certain seasons, then I think we've lost the battle. We've lost the battle because, and this is historically what's troubled the electric vehicle, in that it just didn't meet enough people's lifestyle. So we're going to break through that barrier, and as Dr. Burns indicated, that we see many other vehicles coming, and as the commercial goes, may the best car win. Right,
and how much will the Volt cost?
The Volt or?
The Volt.
Well, where's my PR guy? We plan to announce our pricing later this summer.
Not even a range? Can't give us any indication?
No, let me comment here, because I think Dr. Sachs really referenced some key points as well. In order to support the technology during its early stages, we're very pleased that the federal government and other entities are providing sort of that cushion, if you will, to get people interested and adopt the technology.
Okay.
The Volt itself is a Chevrolet,
right?
And the desired state is to make it a little bit more than a comparable compact car. So we believe when one compiles ultimately the value proposition, which includes perhaps all the Onstar and mobile app features, the difference between electricity and gasoline, the incentives, and interestingly enough, I think there's going to be some very significant announcements in the next month or two on the launch regions that ultimately I think you'll find that this car may be the equivalent of less than a $30,000 car.
Great, thanks.
So be careful about the price tag question. I will. That's why my answer was a little lengthy.
No, but you gave us a category to think about. And now I'm going to throw out a question to all of you and then ask for some questions from the audience. But again, we talked about how New York is such a unique market. What's the role for electronic vehicles in mass transit or in the taxi fleet here? What steps need to happen for that to move forward? Obviously, as Art said, we all rely on electric transportation more than many cities through the subway, but what else has to happen here? Art, maybe I'll start with you, and then I'll come back to you, Dr. Burns.
I think the point you bring up about fleets, I think that is a unique opportunity. It was speaking to some of the folks who do package delivery, who I won't name specifically, but they specifically mentioned that their average daily route in Manhattan from garage out to the route that they take to deliver the packages back to the garage is a little less than 9 miles. So that kind of vehicle use.
That's interesting. So local deliveries.
Local delivery,
Uh-huh.
and so that kind of fleet. So delivery fleets, taxis are a bit problematic because because of the cost of the medallion and all need to be out on the road.
Right.
There doesn't seem to be much opportunity for recharging.
Refueling.
But the idea of fast charging and of battery swap outs might fit that fleet.
Yeah, that's interesting.
So, and there may be other technology solutions.
Dr. Burns?
Yeah, I want to go back to the point I made about mass earlier. Actually, a year ago, I was in New York City, and we revealed a vehicle. At the time, it was called Puma, Personal Urban Mobility and Accessibility. It was a picture of Segway, and widen the wheels, and have two people sit on it and cover it. The vehicle will weigh about 750 pounds. Now, a transit bus is 64 passengers, so that's 32 two-passenger seats. 2 rows of 16 seats. Now picture 32 of these Pumas following each other closely side by side. You can actually move more people in those vehicles than you can with the bus. The 32 weigh less than a bus, so they're more efficient, and the 32 will cost less than a bus. The key is to redefine how we're moving around and use the technology, communications, transportation, and energy technology, the convergence of that, to change the game. The DNA of the car is 120 years old. How many industries are out there that have 120-year-old product DNA? And the reason it's 120 years old is that there's a codependence that's existed that fed on itself. So we need to change that dynamic. So I think there's a very exciting future in New York City. Transit is great. I'm not saying it's not an important part of it, but if we can move around without the taxi cabs in New York City, do it very quietly, do it very politely, so we're not running into each other, do it without any emissions, utilize the electric grid, but in this case, you're making much more efficient use of the electricity.
Right.
3 kilowatt-hour battery versus a 16 kilowatt-hour battery on the Volt. So I think there's huge opportunities in the city. I do want to encourage everybody to pay attention to what's going on in Shanghai at the World Expo. The purpose of that expo is better city, better life. They're looking at the year 2030 through the lens of a major Asian city. And I think not just for transportation technology, everything is going to be critically important, and you can pay attention to it not just by going there, but by seeing what you can get off of the web. It's going to be really fascinating.
Great. Do we have any questions in the audience?
Let me follow that up
I'm
with
sorry.
just one point. And
of
that
course.
is that the thing I'm most worried about in terms of electric transportation in New York City is the bad shape our subways are in. So you guys out there ought to think about how you can help the MTA to modernize the most efficient electricity transportation system that we already have. What does it carry, 5 million a day? 5 million a day, 24 hours a day, and it's in bad shape.
Thank you.
Hi.
Yes, sir.
Vijay Modi had a question. First of all, loved the panel, need more events like this. 2 questions. One is, we talked about integration of transportation and the building or the home. Today, 75% of end use in a home is for hot water and space heating. Nearly all of it coming from fossil fuels. How can that be thought in an integrated way across transportation and electricity as well? So that's one question. The second question was, in my hometown in India, they legislated that all taxis be compressed natural gas. They are low speed, they don't look that much unlike the Puma, but they are called rickshaws, and they get more than 100 miles a gallon equivalent. If our grid is going to come from natural gas before it comes from solar or wind, what do you think is the role of compressed natural gas for vehicles?
Let's start with the first question. Who would like to take that on?
Can I just comment on those figures for a heating and hot water using electricity? That's not the case in New York City.
Heating and hot water from gas and oil.
Then I misunderstood the question.
Right. So I'm sorry, tell me your question, the first question again. Could you clarify?
So the question was, how can the heating and hot water end uses, which are all fossil fuel derived from oil and natural gas, how can they be thought in an integrated way across transportation, electricity, and heat? The panel was addressing the integration of transportation and electric. And my question is, how did the third end use, which is for heat, and
Yes.
art is perhaps the
Yes, there are some future technologies that go to that kind of integration. One of them is a home fuel cell embedded in the hot wood heater that creates electricity, and the waste heat heats the water, and the water is used for space heating as well, and then the electricity could be used for charging a vehicle or for other uses of electricity. So there are appliances that have been developed that are beginning to look at that level of integration.
How about compressed natural
I'll
gas?
I'll take that. I'm really glad you brought up natural gas. 10, 15 years ago, the United States was planning major ports to bring liquefied natural gas into the United States from Russia and the Middle East because we were concerned we had a shortage. Over a 20-year period, technology has been developed called hydraulic fracturing, basically, to extract natural gas from shale deposits, of which the U.S. has 4 very large shale deposits. The reserves now in the United States for natural gas are very, very large. And that's exciting because natural gas is relatively clean fossil fuel versus oil and versus coal. Now there's 3 ways you can use natural gas for transportation. You can compress it and burn it in an internal combustion engine. You can burn it at a power plant, make electricity for a plug-in electric vehicle, or you can strip the 4 hydrogens off the carbon and make hydrogen for a fuel cell electric vehicle. So go back and do the calculations, engineers, and ask yourself, which will you go farthest on with a cubic foot of natural gas? Putting it in a compressed engine and burning it at a power plant for a plug-in, or turning it into a hydrogen. And in fact, the plug-in and hydrogen option are much more attractive than the internal combustion engine option. There is an application of compressed natural gas, I think that's going to make a lot of sense, and that's with Class A trucks and deliveries within cities and things, because the diesel engine doesn't have a lot of good alternatives. So I think compressed natural gas can play there. And while I have the mic, I also want the engineers to do the calculation. If you have an acre or a ton of biomass, and you can turn it into ethanol, or you could burn it and make electricity for a battery, or you could turn it into hydrogen. Which way you go farthest on? And in that case, you go farthest with the hydrogen and the fuel cell. The good news is we have a lot of biomass that's non-food based. We have a lot of natural gas, and you can use each of those 3 ways for transportation. Now, come on, there's a solution just sitting there for us to be had on domestically produced energy, if we can get off the oil and get onto electrically driven vehicles and these other options.
Artie, did you have something to add?
Yes. There currently are 2 or 3 compressed natural gas stations in New York City, and the number is growing. And the principal vehicles that come up to that pump are taxi cabs and some small trucks. So the infrastructure already exists, and the plan is that infrastructure will be increased. What is missing now is vehicles that are built for compressed natural gas. Right now, most of those vehicles, perhaps all of them, are conversions, aftermarket conversions of commercially available vehicles. So we agree that electric vehicles are one of several alternatives: compressed natural gas, biofuels, and others are out there as well.
Roger, did you have something to add?
One last comment. I was with Dow Chemical, has a city in Texas, an entire city called Freeport, which has got 10 petrochemical plants. And we were talking about transportation uses of natural gas. It's a tremendous waste to take natural gas and propel an automobile with one person in it, compared to making plastics, they would take first claim, I believe, on the natural gas, and electricity generation would take second claim, and I doubt if transportation is very high up on that list.
Good. Next question.
Yes, I'm Jim Motivali from the New York Times, and I do think one of the elephants in the room, which we haven't addressed, is the question of, we are in New York City here, and most people do live in apartment buildings and park their cars on the street. And I was talking to a fellow from Kaloom, which is one of the big charging companies, and he had a BMW Mini E. They told me it took a month for him to get approvals through the city government to be able to get his charging station, because you have to go through the city and you have to go get you have to have inspectors come out. The whole process is very delayed.
This is for a residential home?
Yeah, to have a charging station or a garage installed. This is for people who have garages. It takes a month to get that approved. So we're looking at people who park cars on the street in New York City, where I imagine a tangle of different agencies have jurisdiction. And one can imagine that this could be a very prolonged process with that I'm not sure we've totally worked out yet. We're sort of addressing this on the macro level, and I think we need to address it on the micro level too. Like on the street, how do you charge your car? How will we charge our cars?
Artie, can you?
I'd like to second that observation, and I think that unfortunately Professor Sachs left. That is a domain where policy at a local level would be very beneficial, to be able to untangle that series of approvals that are needed to get that charging infrastructure. There's also the emergence of commercial entities that are looking at that very problem and trying to figure out how they could perhaps build charging infrastructure in the streets.
So you have private companies that would act as
just like you see
contract.
Right, just like you see the booths at bus stops, just like you see telephone booths on the sidewalk, that there'd be some streetscape system that would provide charging infrastructure for vehicles that are parked at the curb.
Tony, what are you? How big an issue is that for?
Yeah, let me comment a little bit. Jim, good seeing you, by the way. Thanks for coming. From a Volt perspective, we recognized some of the administrative challenges associated with that, and that's why the Volt is very much geared towards not special apparatus, but basically find a plug in the wall and charge your vehicle overnight. Now, in big cities and environments like New York, that is certainly a different challenge. But I hearken back to the challenge in the context of, is it a technological challenge, is it an invention, or is it an organizational challenge? I like to tell the story when we first were questioned and queried about our ability to make batteries, General Motors. And I fondly told them the story, did you know that General Motors had batteries on the moon? Because General Motors was the battery developer and manufacturer for the 3 lunar rovers. We also designed the electric propulsion system and the software for Apollo 15, 16, and 17. It just so happens that Apollo 17, the lunar rover, went 22 miles. I don't know if it's real world miles or lunar miles, but 22 miles. And unfortunately, the program was scrapped due to no recharging infrastructure. So, point being is, if we can do these kind of technological accomplishments, this is a little bit why we're here today. I think this is a little bit why we reach out to you and share with you the progress we're making. This is sort of, it takes a plug-and-ready community.
Right.
And I think Jim's point was spot on. I mean, if we can just cut through the permitting process. I was with David Sandalo yesterday, Assistant Secretary of Department of Energy, and he says he thinks if we can't accomplish that, and certainly the New Yorkers I know, if they band together with the key leaders we see here today and the thought leaders we see around the area, I'm confident we can figure out a way. Now remind you, early on, we won't have that many vehicles, so it's the perfect time to start figuring out how to establish a main charging station for someone. In most cases in the Midwest, it's someone's garage in their home. or at a place of work. But it's a wonderful opportunity and challenge for us to collectively problem solve.
Great. The gentleman there?
Hi, my name is Bruce Lincoln. I'm the entrepreneur in residence here at the Columbia School of Engineering. Where do you see opportunities for creating new jobs that could also help stimulate economic growth here in the city of New York?
Let me start off a little bit with my home state, state of Michigan, which has been very, very hard hit during the last economic time, and just give you some factoids on what we've accomplished over the last year or so. And I think given the talent that you have here and the resources and the like, I think the other opportunities abound. In the last short period of time, we have invested over $700 million in the state of Michigan. And that has provided us a...
That's just for the Volt?
Just related to the Volt. What that has done is it's spun off little spin-off industries. It's involved universities because you need trained and talented individuals, and you need software and connections, if you will. So that includes a vehicle assembly plant in Detroit-Hamtramck, a brand new battery plant in Brownstown, Michigan, state-of-the-art. We've had 2 investments in the state-of-the-art, probably world-class battery laboratory facility. Cell manufacturing facility, if you include beyond the $700 million I referenced in some investments outside the company. We're creating a corridor, a hub of this activity. What I would encourage New York to do, and I think you guys have the wherewithal, and I've seen some great signs of organizing your area, you create a hub of a plug-in readiness, and then there's a whole host of different opportunities, whether it's solar panels on top of the charging stations, at various venues, whether it's places of business, whether it's small fleets. I think the learning exercise of generating some of these little initiatives will spawn other opportunities. And I think the most interesting opportunity is the education and the knowledge base that you accumulate. Those that move first in this space, I'm convinced will think of the next best idea, and then obviously get some benefits. And I personally think the use of the battery, and if you get some familiarity with using the battery and charging it, can do some wonderful things. As I talked about collecting renewable energy, I think at some point in time we may have batteries in our homes. And you want to talk about an interesting perspective that provides and affords us relative to having control of your own energy. So great question.
All right.
Yes. The car increasingly, as was pointed out, is becoming an electronic device and software. And the intelligence and the development of that software, and the technicians and the types of level of capability that are needed for that provides a unique opportunity for education as well as for the training for the trained mechanics and technicians. There's some great work going on in the state and specifically in New York City in developing advanced battery technologies. There's some amazing technology I saw at City College. So we see work and potentially the materials that those batteries are made of are available and could be fabricated anywhere. As a matter of fact, it makes a lot more sense to fabricate some of those batteries closer to the use. So there's, I believe, this displaces jobs that are offshore now in the production of the fuels that we use now and brings them onshore. And New York City is a great place for those kinds of opportunities.
Can you imagine the idea of what we're talking about here, of displacing all the petroleum that we import with domestically created and produced fuels, with the the new inventions, with the kind of the 6 technologies I referenced, and again the talented individuals we have on this campus in this state. So I'm going to do a little plug. Pam Fletcher is here. She is our chief engineer for propulsion systems on the Volt, and she has other responsibilities in plug-in technologies and hybrid technologies. So if there's any engineers who are interested, Pam, I'm sure she'll collect your resume, because again, we are intending to grow this business, and to your very point, to create some green jobs out of this.
Great. Thank you. Next question, please.
My name is Robert Sinclair Jr. I'm the media spokesman for AAA New York, and I write the test drives for our magazine, Car and Travel. You mentioned the psychological barrier of range anxiety with electric vehicles. I'd like to throw a couple others out there. Number one, charging times, which you kind of touched on. The idea that with one of your competitors, Nissan Leaf, it'll get 100 miles on a charge and then conceivably need a 6 or 7 or 8 hour charge would seem to be a barrier. And also performance. You talk about the unique driving environment here in New York. We've got a lot of poorly engineered roads, which mean you have to accelerate very quickly to get in front of that 100,000-pound big rig. And it seems that electric vehicles are pretty much down on performance. You know, the Volt has a sport mode. I got to drive it briefly, and it seemed like it would be a way to deal with that problem. But for the most part, electric vehicles are pretty slow. And a couple other things. With the batteries that are going to be in these vehicles, what happens when it's time to get rid of them? Are they going to be recyclable with the lethality? Are they toxic or what have you? And with all these vehicles of the future going to be connected and they're talking to each other and not crashing, is our driver training program going to be put out of business?
We are talking about some...
Do you guys want to handle that?
Yeah. I'm afraid that one's coming to you, Tony.
Great question. I'm glad you had the opportunity to drive the Volt. So remind me as we go along on a couple of those areas, but let me start a little bit on an area I know quite well, electric vehicle performance. One of the beauties about electric drive, and this comes right from the heart from having driven as many cars as I've driven, is the delightful driving experience. If the vehicle is designed correctly, electric drive gives you a couple of things. The term instantaneous torque sounds very technical, but it is very exhilarating. Anyone who's familiar with gasoline-powered cars, they work their way up to a torque curve, your engine revving, they get the appropriate spot, and that's where you get your peak power. On a vehicle like the Chevy Volt, an electric drive vehicle, you get your instantaneous torque immediately. Matter of fact, the vehicle you drove, we had a lag put in so you wouldn't burn the tires, our prototype tires. So just so you know, even in regular mode, the Chevy Volt will be 0 to 60 in less than 9 seconds, and the instantaneous torque will have the feel of a car that's maybe about a 250 horsepower V6 equivalent. So if the vehicle is designed properly, electric drive and the instantaneous torque is a wonderful experience for managing the scenario and situation you referenced. Do you want to jump in?
Stop and ask you a question, because I too had a 65 Mustang, and I know Dave and I would like to have it make really cool sound. Are you going to put any kind of like false?
Well, one of the things about the technology we're talking about here, and all the software and the advanced nature of it, is you guys are familiar with 1.0, 2.0, 3.0, and this is why we come here. So don't be surprised if some future Volts, not 1.0, may offer you some of that capability. So let's get back to the question.
So what about the disposal of batteries? Does it present different issues than conventional car batteries?
Let me kind of rewind to the comments I made. We immediately took the step in saying, take battery technology and extend it and push it as far as you can relative to long-term performance. That gets the ability to use the kilowatt hours of energy, the capacity, as long as possible, because the technology is relatively robust based on our testing of effectively millions of electric miles on our cyclers and on the roads. So the Volt battery, for example, if you would consider a 0 to 100% capacity range, we use a little over half the battery pack. That allows it to last a long time. It allows us possibly to modify the state of charge window in the future to give you consistent range performance, and allows us to extend the life of the battery. We also condition the battery. When it's plugged in, it is kept at a temperature. We've referred to the battery as our diva. She is temperature controlled. She's got her own heating and cooling system, liquid cooled system, and the very intent is the longer you can extend the life and usable life of the battery, the less you have to worry about recycling. When the battery, after 10 years, is considered no longer automotive grade, it still has about 70% of its capacity available, and theoretically, a Volt could still be driven, but instead of 40 miles, you may now get 28, 25 miles, and you just use the extended range feature more. So you could drive it even longer. So we're pretty convinced and confident it'll be 10 plus years in the car, plus a life outside of the car. And then to your final question, as you look at the various components, the electronics, the metal, the plastics, and how you extract lithium, it is quite easily to recycle. Now, there are no large-scale commercial businesses today that do that. There will be. There will be.
What about the future of reducing charging times?
Again, in a Volt, 240 volt is a 3-hour charge. The Nissan Leaf you referenced is an hour charge, 240. It's a 16 plus regular. So we chose a little less battery because it costs less, weighs less, gives you more room in the car, takes less time to charge, and if you get an extra plug-in, you don't need to have that really big battery. So this is the way we've chose the solution. There is some interesting things, and you might want to comment on fast charging because I think that's an interesting technology.
There are several other options, and again, realizing this is a 1.0 technology, the high voltage 440 volt level 3 as it's called charging, though that has a very significant impact on the grid, so it requires a kind of an intermediate storage, DC storage usually, and that allows for recharging within 10, 15 minutes is kind of the kinds of design basis and for that kind of a system. Also, there are other ideas of creating battery packs that could be swapped out, so the car would be equivalent to being gassed up at a pump. There's also the kind of use pattern studies that need to be done. Typically, a car might be used an hour or two a day. So depending upon the pervasiveness of recharging, that leaves 22 or 23 hours to recharge. So a 6-hour charge is not at all not unfeasible. It's, matter of fact, it fits very well, but that would require pretty pervasive availability of places to charge. So this whole question and what the Leaf people, what the Nissan people told us, is that that 100-mile range is something, because we asked the same question, that 100-mile range is really, covers a huge percentage of people's driving patterns. And what they found was just the availability of even a very few, 1 or 2 or 3 charging stations in a downtown area alleviates the psychological anxiety. It's not a real issue, it is an anxiety. So that as drivers are more used to that kind of fuel and adjust their thinking, that's less and less of a problem. In Manhattan, I have range anxiety every time I bring my car in because there are almost no gas stations. So that's the challenge that we see. I think you could tell your membership, I'm being one of them, that this is something that's going to be a lot of fun to drive. I've driven a bunch of these. They're terrific vehicles. I wish these guys well, and I wish them success, both from the viewpoint of I like to drive and it's a terrific car, but also that we happen to be the electric company, and it represents an opportunity.
We have no intent of eliminating your driver programs, trust me.
One last point on that, and Artie could correct me, but in the city of Paris, the city government is putting in the charging stations.
Yes.
Any sign the New York City administration might do something like that? No, not yet. Thank you. Thank you. The last question, please.
Sure. I came a few minutes late, so hopefully this hasn't already been covered. But looking at sort of municipal charging stations or private ones, I was wondering, maybe Artie would know this, if there were companies like Better Place that's going on in Israel, and I think in Denmark, if there are private companies like those that have been in conversations with you, or that we can see the seeds of a swapping program going in already. And my second very quick question was if there have been any either municipal or company fleets or things like programs like Zipcar that have put out like a potential initial commitment to get us from the early adopter phase to bring this up to scale, if there have been any sort of commitments of company fleets.
Good question.
The first question, there have been at least 3 commercial suppliers of charging systems that have gotten to speak to us and describe their plans. They're very interesting, very different approaches, Better Place being one of them. And they're just trying to figure out what would make sense for New York City, and we're working with them to try and help them. The other is the other question in terms of
like municipal, has there been any fleet commitments from companies or maybe like car rental place, places that would have the infrastructures maybe already in their lots where like a zip car or something where they could already, people might be using them for shorter amounts of times, they would have that.
Right. The way I understand zip cars is that they park in commercial facilities, so they would engage in some arrangements with those, and it would seem reasonable that they would do that. There have been a number of fleets that have approached us that were planning, or at some stage of planning, of putting in charging infrastructure at their facilities where they would have 50 or 100 vehicles that could charge. So those conversations have started. I wouldn't characterize them, though, as serious. They're just exploratory.
Okay. So there haven't been any sort of initial commitments like the Better Place
program.
program.
Is the parking garage, people who own the large parking garage.
Those, well, I can't specifically say who they are, but the first one, when we were talking about public, yes, we have had 3 significant providers of parking that have approached us. People who own fleets, it's more exploratory at this stage.
Okay.
Thank you.
Did that answer the question well enough?
Yeah, I guess I was sort of looking for names, but for now, I'll take
Yes.
it as to be continued.
But and these conversations started about a year ago. And I know their thinking and their levels of commitment are serious, and as they see the vehicles coming to market, they're looking to be early adopters. They want to differentiate themselves and create a place, and I think this is all going to be happening very soon.
Thank you. Well, I'd like to thank all of our panelists very much. You've been great today, and I want to thank Columbia and the School of Engineering, and also the audience for asking such good questions. Thank you very much for coming.
Thank you, guys. Thank you.